This is Chemistry Hangout. I want to believe you are doing fine today. I want to welcome you into another wonderful lecture on this channel. If you are just new to this channel, subscribe to this channel and turn on the notification bell so that when we release a video, you are going to be notified. I want to say thank you to people that have reached out to us. Thank you for your words of prayers. Thank you for those messages. We really do appreciate those messages. God bless you. I want you to pay maximum attention today because we're going to be analyzing the specimen we have for the WAEC for this year. And like we always do, we just try to do this to encourage students and to tell you that these exams are not really difficult if you can, if you can really follow the instructions we have been giving. So this very particular time again of the year, we are here to do the analysis. We are going to be explaining it step by step like we always do. Like I always say, this is my own opinion, but I say that if you have, if you have listened or you have adhered to the instruction that you have been given on this channel, definitely on the exam day, you are going to smile. We are going to do the possible test, the maximum possible test that can be asked on that day. We are not saying that is all you could be asked, but we are going to do all and try to exploit, we will not leave any place uncovered. We exploit all areas so that when you come into the exam hall, you are confident. And if you have watched this video over and over again, then you will be able to do a whole lot of things. So very quickly this year, let's look at the proposed question for this year. The proposed question. It says C is a mixture of an organic and inorganic compound, right? Carry out the following exercises on C, record the observation and identify any gas involved, state the conclusion you draw from the result of each test. Then they said put all C. So like we know, the specimen for this year, of course, you for some of us that don't know it, or for some of us that have seen it, they said the specimen is copper sulfate and glucose, and that's what we are going to be doing. And this is a proposed question, so we want to do it step by step to understand. I am not saying this is the way the question will come. My number A might be their own B, their B might be my own A, but the test will not change. And that's why I want you to pay maximum attention. Yes, I want you to pay maximum attention as we do the test step by step. And I'm sure you are with your pen and your book so that you can jot something. And if you have questions, you can put it in the comment box section. We are going to reply you as fast as possible. So let's get started. So this is our specimen. Our teacher would have done this on that day. They would have, do all this. So they said that the first instruction there is put all C. So that's the specimen C, right? Put all C, but I will not be putting all, it depends on the center you are and how much the salt is. But you might still want to use this some other time. So I'll put just few, but put all you can. They are not there. They are not there when you are putting the salt. You get, just make yourself comfortable while we analyze this very particular thing. So we put, let's say this is the all of C in a test tube. Let's put as more as possible. Okay. So let's say this is C now in my test tube, right? And they said add about 10 centimeter cube of distilled water. So let me say this is my distilled water. Let me just measure that with my discretion, about 10 centimeter cube. So this 10 centimeter cube, and what did they say? They said shake thoroughly. So let's shake thoroughly. Let's shake. So let's shake it. Very important. So as we shake, let's have our test. Okay, let's have our observation, right? Let's have our observation, and let's have our inference from that. Okay, so we have this. Please pay maximum attention. Then we have this. Okay, so the first one, please, like I always say, that this is my own opinion. We just try to do justice to all those things. Some people might disagree with me, it's fine. Some might agree with me, it's fine. But this is just my own analysis. And when it comes to practical, I always want to be practical as much as possible. We're going to be recording what we see because this is a practical examination. So we're going to be recording what we see gently, step by step. And that's why we are doing all this. So the first one, they said put all C. So we can now say 1. Look at this. They wrote A, I wrote 1. That's not correct. That's wrong. Let your numbering, let it correlate with the question. Very important. So this is supposed to be A now. Okay. So we say sample C sample C, right, plus distilled water. Sample C plus distilled water. Did you see that now? Sample C. Let me still shake as I wait for it to dissolve totally. That's why they said shake thoroughly, please. So we have to listen to simple instruction. Did you see that now? Did you see the solution? Did you see that? Let's shake thoroughly. Very important. So that we can be sure of anything we are recording. Okay? So very, very important. We have to shake thoroughly. So that we'll be sure of what we are recording. Okay? Look at that. Did you see? Look at what we started with. Did you see the sample we started with? Look at this. Which means, they said, look at something. They said C is a mixture of an organic and inorganic compound. Which means this specimen we are using, we have two things there, right? We have two things in this specimen. So they now said we should shake it. Look at this. You can see it's very soluble. Very, very soluble. And if I say it is soluble, what is the color? I'm seeing a light blue, right? So I can say the observation now. It dissolves, right? Completely in water, right? To form a light blue solution. Did you see that? I'm taking two characteristics there. And what is the characteristics I'm taking? The solubility and the color formed. Do you get that now? So the solubility is dissolving completely. Look at that. Can you see? Completely in water. So, and it forms, on complete dissolution, is forming a light blue solution. So I said, dissolves completely in water to form a light blue solution. So what is the inference? Don't forget they told us here already that C is a mixture of organic and what? Inorganic compound, right? So, what is my inference here? Since everything dissolves, no residue. No residue. That's why they are not telling us to filter. Because everything dissolves. So I can say soluble compounds. Did you see that now? So the mixture of C contains soluble compound. They've told us that one is inorganic, one is organic. The two of them are compounds, right? So for it to now dissolve, can see completely in water, it means that the mixture of C contains soluble compounds. So because the sample C, like we have said, has two compounds in it. So the first test, everything is soluble. It means that the mixture, this mixture, we don't know, the two mixtures, they are saying that it contains one soluble compound, and that's why the observation is that they dissolve completely in water. Is that clear? Very clear. We can have different words. Some people can say C are soluble compounds. Did you see? But the solubility has to be there. Did you get? Some people say C contains soluble compounds. Some people say sample C is a mixture of soluble compounds. Did you get that now? But what is it we are interested there is what? The solubility. Did you get that now? So let's move to the second test. Shake thoroughly and test with litmus paper, then divide into what? Into 4. So let's test with litmus paper. Let me use red first. Let me use red. You are just doing every possible test. Look at that. Can you see it's not changing red? Did you see red? It's not changing red. So let's see blue. Let's see blue. Did you see blue? Did you see it's changing blue? Did you see? To red, right? We are not saying they are going to ask all these, but like I've said, we will explore every areas. So anywhere they are coming, even if you are a very intelligent student, if you understand this thing I'm doing, it will ease your stress study. Because when you see that they are saying put litmus paper, you know, oh, this is the result we got when we did it. So plus distilled water, then now plus litmus paper. What happened when we did that? You see that it is changing blue to red. So we can say change blue litmus paper red. Right? So if you change this blue litmus paper red, it means this solution is acidic. That's the meaning. So we can say the solution of C is what is acidic. Clear? Very correct. That's why we said we are recording what we see. No tension, no pressure. Just do this. It's interesting. Just do this, and you're recording what we saw. Very easy, what we saw. So plus litmus paper, change blue litmus paper red. The solution of C is what is acid. Can we move on now? Very interesting. So the next thing, then we go to what? To Roman figure 1. They said to the first portion add. Okay, they said we should divide this into 4 portions now. So let's do that. Let's say this is 1. Let's say this is 1. Let's say this is 2. Right? I'm just trying to follow the instruction. Let's say this is 3. Right? 3. And let's say this is what? This is the 4th one. So we are just trying to. So let's leave this. This is what we started with. So let's say this is the 4th portion now. Did you see? Very clear. So the next one, they said add sodium hydroxide in drop and in excess. This is my sodium hydroxide, right? In drop and in excess. In drop and in excess. In drop. Did you see that? Did you see something like, something that is, you can see, then in excess. Did you see? Like, did you see? Did you see? If you look at it now, did you see that now? So we have what? This is a blue solution, right? So, but look, let me shake so that I'll show you something. Look at the down of the test tube. You can see that it is insoluble. The blue is now insoluble because it's like it's forming a precipitate at the down of the test tube. Can you see? So what do we record there? So Roman figure 1 now. Roman figure 1, to the first portion, add sodium hydroxide. So, first portion, right, of solution C plus sodium hydroxide in drop and in excess. So, in drop and in excess, you can see. Did you see? Let me add again. In drop so that you see in excess now. Did you see something that is forming? Did you see it's insoluble? Can you see those precipitates now? Did you see them now? Okay. So let's start. We can now say in drop we have blue gelatinous. All those terminologies are important. Blue gelatinous precipitate. Right? Insoluble in excess sodium hydroxide. Do you get that now? A blue gelatinous precipitate formed. Let me put that so that you can see. So a blue gelatinous precipitate formed at the addition of excess sodium hydroxide is still what? Insoluble. So and when we see blue color like that, when we are reacting with sodium hydroxide, then we say copper 2. Please, the ions, the valencies are important. If you write just copper, you have written elements, copper elements, and that will be very, very wrong. So note the ions there is copper 2 present because you can have copper 1, right? So it's copper 2 present. Did you get that now? So that is that for this. Let's move to our second portion now. So let's take the second one. Did you see that now? Then they said to the second portion, right? Add that's Roman figure 2 now. So we can say Roman figure 2. To the second portion, add ammonia in drop and in excess. So here's my ammonia. This is my ammonia already prepared. And that's why as teachers, we must prepare all these things for students to make the work very easier for them. So let's see. Don't forget, this is portion 2 now. So in drop. Did you see that now? Did you see? I'm not seeing any precipitate here. Did you see? So in excess now. Let's go in excess and see. Can you see everything dissolved? That's why it's a practical exam. Did you see? Did you see that now? So you can now say second portion of solution C plus ammonia, right, in drop and what? In excess. Because if sodium if ammonia did not dissolve it, you will still be seeing precipitate, like something that is insoluble beneath it. But you see, very clear solution. It dissolves all the precipitate, right, and formed. Did you see that? It's not an ordinary blue now. This is a deep blue. Did you see that now? So, second portion, precipitate dissolved, right, to form a deep blue solution, and that copper 2 plus is confirmed. That's a confirmatory test for copper. Yeah, that's a confirmatory test for copper. When you see it forming a deep blue solution on the addition of excess ammonia solution, it is a confirmatory test. There is no need of saying copper is present. This is confirmed. Copper is here. For it to have formed this deep blue solution in excess sodium, in excess ammonia, so copper is what? Copper 2 plus is confirmed. Did you see that? Very clear. That's second portion. Did you see how interesting it is? No stress, no tension. The one for this year is easier. No stress, no tension. So the third one now, we pick the third one now, right? So 3. Oh, sorry, you can see my labeling now, please. Just check the labeling on that way. So let's say this is B, figure 1. They say that the third, that's third portion of solution C plus barium chloride. Right? Plus barium chloride. Do I have my barium chloride here? Yes. That's why as teachers to please educate us, let's prepare the right reagent in the right proportion so that the test will be very easier for the students. You know, when they do all these things and they see it, practical demonstration is very, very important. It excites them and they want to see like, oh, this thing is actually true. It's just like practical is just like an affirmation statement from what you have been reading in textbooks. Do you get that? So, and we have said that if you cannot prepare those reagents, you can actually reach out to us. So, barium chloride. Look at that. This is the third portion, right? So let's see. Barium chloride. Did you see? Did you see what it's changing to? Did you see? Did you see that the white is staining the... Look at it. Did you see that the white is staining the walls of the test tube? And it's just like a chalk. I don't know if you know, like you are grinding chalk and you are putting it in water. I can see. That's what it's looking like. Did you see? Did you see that? Did you see? So, very, very important. Did you see the color? Like you have a chalk, like you grinded chalk and you put it in water. So let's record at the addition of barium chloride, we can say now a white chalky, because it's not a pure white like that. Do you understand? It's not a pure white like that. So we can say white chalky precipitate formed. So, and if we have that, that's for barium chloride. We have said that before. If you have been following this channel, we have always done this barium chloride test. And if you see that 3 ions are likely to be present, 1, we can have our SO4 2 minus, CO3 2 minus, or SO3 2 minus present. Some people too will say S2 minus, that's the sulfide ion present. But I just like to record the 3 actually. Some people can do SO4 2 minus, CO3 2 minus, SO3 2 minus, S2 minus. But I just like these 3 because, you know, they are radicals. So I just like to pick these 3. Anytime I work with barium chloride and I say white chalky precipitate, I just want to pick these 3. Okay? And some people will say a white precipitate form. What is important is this color and the precipitate that is formed. We are still correct. Okay. So that's third portion of solution C plus barium chloride. You now said what? By excess dilute HCl. So let's see. So I prepared already HCl. Did you see that now? So let's have in excess now. In excess. Did you see? Now, if you look at this, the excess dilute HCl did not dissolve this, because if you dissolve it, you will not be seeing, you'll be seeing like a colorless solution, meaning it has dissolved, but it's not dissolving it. It's still same thing, still the white chalky precipitate that is staining the walls of the test tube. You can see it's still the same, or the addition of excess, which means that even when I added excess dilute HCl, what happened? The precipitate did not dissolve. So on addition of plus, right, plus dilute plus excess dilute HCl. Do you get that? So I can say the precipitate did not dissolve, right? So and if the precipitate did not dissolve, that's what? SO4 2 minus present. Did you see that now? If the precipitate has dissolved, it means it's either this or this. Then we can now do a further test to know which of these two is there. I don't know if that's clear. If I'm working with barium chloride, I have a white chalky precipitate, I'm recording these three to be present. If I added HCl and it dissolved, let's assume it dissolved, then I'll pick these two, because these are the likely radicals that can dissolve in HCl. Then I cannot do a further test. It depends on the practical. But since it did not dissolve, it is only this. Out of these three, this is the one that will not dissolve in excess HCl. And that solves our what? Look at it. Look at the down of the test tube. Did you see? Did you see the precipitate that is there? Did you see that? Did you see it did not dissolve? You get that now? So it didn't dissolve. So these things are practical. If you look at it, did you see? Look at it. You'll be seeing a white like chalk inside. So that's the third one, right? So the fourth one now, we'll look for somewhere to actually do that. I think the body's exhausted. Okay, so the fourth one, for the fourth portion, add Fehling solution A and B. Let me say something here. Add Fehling solution A and B. You know, this is the fourth portion, right? They said we should add Fehling solution A and B. The first instruction, add Fehling solution A and B in same measurement. Which means if you are measuring 3 centimeter cube of Fehling solution A, you are measuring 3 centimeter cube of Fehling solution B. Did you get that? So that's why I have my measuring cylinder here. So I want to measure 2 of Fehling solution A, 2 of Fehling solution B. Then I can now, add it to this. So let me measure. This is my Fehling solution B. This is my Fehling solution A. So I can measure this okay, so let's have just 2 centimeters of this. Let's have just 2 centimeters of Fehling solution A. So you can see this 2 centimeters. That's what I am using. 2 centimeters. Some people say, oh sir, can we prepare the Fehling solution A and B? Of course you can prepare it, but for ease work, for you not to stress it, you can just get it. You can prepare the Fehling solution A actually, because it's just like a compound, a solution of copper sulfate. But in Fehling solution B, there is something we call a tartrate. You might not have it, you'll be looking for that. So why are you looking for that when you can get the one that I prepared? You can always prepare your dilute HCl. Those ones will not come in their diluted form. Sodium hydroxide, ammonia, barium chloride, all those ones you can prepare. But for Fehling solution B and A, I would advise you to always get it. Then that's A. Then the B now. Fehling solution B, 2 centimeters also. 2 centimeters also. Is it 2 centimeters? Oh, this is much. Let me read, because I said same measurement, please. Same measurement. Same measurement. So that it will give us, okay, do you see that now? 2 centimeters. So this is Fehling solution A and B. And where's my first two, right? So we can say fourth portion of solution C plus what? Fehling solution A and B plus it. That's what they told us. Fehling solution A and, let me say, A and B plus it, right? So, and I said, for us to get an accurate result, the A and B must be in same proportion, right? So let's go. So this is my fourth. Now look at something. I just saw it now. Look at this on standing. Did you see why we said precipitate did not dissolve? Did you see it? Very clear. So sometimes if you leave those things for a few minutes, but because of our time, we cannot be doing that. Okay. So that's it. Look at this one too. that we said is insoluble. Did you see? That's why we said for blue gelatinous, when we added sodium hydroxide. Did you see? So all those things are visual, right? What we can see. So this is the fourth portion. This is my Fehling solution A. I'm measuring 2 centimeters for my own. So that's 2 centimeters. Did you see that? Fehling solution B. This is my Fehling solution B. Another 2 centimeters. Did you see? Like a deep blue now. When I added that, then let's eat it. Let's see. Let's eat it now. Let's eat it. So let me hold it with this. Right, so let's go. Let's see. So this is my form of it now, right? So let's see. Let's eat. So let's take our time. Did you see that? Did you see that now? What's this? This is a brick red. Did you see? Did you see? A brick red. You can see just a mild eating. You can see this. Very clear. These are just, the practical are very visual. Okay? Very clear. So I can say, you can see? You can see that very clear, right? Is it clear? Very clear now. Good. So let's record. Let me put off my gas, please. Okay. So from that fourth solution, so I can say what? A brick red precipitate formed. A brick red precipitate formed. Did you see that now? A brick red precipitate formed. Then what's our inference? A reducing sugar. Did you see that? A reducing sugar is present. Now this is it. This is something. So a reducing sugar is present, or a glucose is present. If that's what you want to do, it's fine. And that's all. These are the possible maximum tests. So which means that they can now decide to give you 3 out of all these things we have done, or they decide to give you 4 out of all these things we have done. But at least from the experience, from our experience, and from we sitting down to analyze it, these are the possible tests on that day. If I hear you saw on that day there are plus litmus paper. Why are you doing the test again? You have already done it. So if you understand this table we have prepared, you should not find it difficult. Imagine you are seeing it on that day. They are saying, so what you need to take note of is the reagent. For every reagent we are using, there is an observation and there is an inference. And that's why even if you are doing it yourself on that day, if you have watched all this video, you can quickly remember what we did. Because all these things are visual. It's insoluble, it's visual, right? It's what you can see. It's insoluble. Look at this. This is a deep blue. Look at this. It's insoluble here. Look at this, which is our brick red. So that is clear. I want to wish you guys success. And that's why you have done all these things. Go through this over and over again. The reason why we are doing this is because we want us to be confident on that day. We want to encourage us. We want to motivate us that chemistry is interesting. Not even only the theoretical aspect, the practical aspect too is interesting. So what we have been reading in our textbooks are actually very, very correct, and we have proved that here. So thank you so much. I wish you success. If you have not subscribed to this channel, click on the subscribe button and turn on the notification bell so that when we upload any video, you are going to be notified. Wish us success. Thank you. God bless you.